Welcome to our third session of our applied data science course using R. This session will be one of the fundamental sessions about the basic functioning of R, and we will mainly be concerned with the topic of object types. To be a little bit more precise, the goals for this lecture today are first to make a small digression and to learn about the use of R packages. So we already talked about R packages before, but we haven't really learned how to use them in practice. And this is something that we will figure out at the beginning of this session. The second topic is to discuss the different main object types in R and why they are relevant for you to know in practice. So we will understand the difference between a word and a number or a decimal number and an integer in R and what that means for you when you're doing your daily work. And then in the third step, we will actually build upon this and learn how we transform one object into another. So that might be immediately obvious if you want to transform a number into a word, but it might not be so intuitive if you want to transform, say, a logical value like true or false into a number. And we will learn how to do that and how this can be helpful in practice. And then we will conclude this session with some useful helper functions and the concept of vectorization. Now, these are two topics that are not strictly necessary to achieve a certain goal, but that will save you a lot of nerves and time in practice. So, for instance, of course, you can create a vector containing the numbers 1 to 10 by just typing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on your keyboard, but that's not terribly efficient. You could also just use a helper function, sec in this case, that immediately creates this vector for you. Similarly, the concept of vectorization is something that is particular to R and that is super helpful in practice because it lets you speed up certain computation approaches in practice. So, for instance, if you want to compute the square root of 10 numbers, the concept of vectorization lets you do that by issuing actually only one command. And the nice thing is that this is also computationally much more efficient than actually computing the square root 10 times. So these are two very useful things we will discuss at the very end of the session. But before that, we first talk about how you can actually build your own work on the shoulders of others by using the packages other people have provided for you. Now, in this video, we are talking about R packages. As you might know, that one very nice thing about R is that you have this great community of people that are doing similar work. They are working on statistical analysis and visualization. So they often come up with routines or functions, or they also create different data sets that are obviously useful for all the other people in the community, or at least a subset of them. And so what many cool people are doing is that they are actually defining objects, defining functions, or saving certain data sets that are useful to the community, and they make it available to all other people of the R community. And they do this via R packages. R packages are basically the best way of making available objects you defined to others. So you could think of an R package as a collection of assignments and documentations of these assignments that people pass around. So like you define a function, you write a documentation of this function, so you save it and you make it available to others. And you're doing that via the use of an R package in the best case. That also means that if you install R, you can use all objects, functions, etc. That you defined for yourself, obviously, and those that are predefined in R. So we figured out about a bunch of of functions, for instance, like the function sum or sec that we've used before. You do not need to define this function, but it's already defined in R, so you can use it immediately. The fact that it is already defined in R means that it is part of base R. So it is basically part of R, whatever you do, and you can immediately use it. Then again, in the session on functions, you did this exercise in which you defined your own function. And you were obviously able to use it after you've defined it. So that's pretty clear. But the nice thing is you can also use functions of others. But in order to do that, you need to install that first. So if I, for instance, have written a function that you want to use, I would be forced to make it available via an R package. And then if you install this R package on your computer, you can use the function that I defined. Now, obviously, there are much smarter people than I am that define much cooler functions than I do. So it's probably most useful to use the packages that these other people do. And we are now trying to figure out how to do that actually in practice. Now, if a package is made available in the official way, it is available on the official R network, which is called Crane. And if a package is available officially, it has undergone some very rough consistency checks. And if that has happened, then you can install it immediately on your computer if you have an internet connection by the following command. So you just type down install.packages and then in quotation marks the name of the package, and then you press enter. Now, if you write down this, you obviously get an error message because most likely there is no package with a name. So what you need to do is you need to write down the name of a correct R package. And in our case, let's illustrate this with the example of the R package inec, which is a package where somebody defined functions that allow you to compute common measures of inequality. Like, for example, the Gini index. You might have heard of it. The Gini index is one measure for inequality. And within the package called inec, there is a function called Gini that actually is a function that allows you to compute the Gini index. Now, if we simply write down the function called Gini, then R is not able to find it because Gini is not part of base R. It is part of the package inec, so we need to install that first. In order to do that, we call the function install packages and we write down the name of the package, inec, that's the name. And now if we press enter, you will see something like this, where R effectively goes in the internet on the CRAN web server and tries to download an installed package. Usually that's quite quickly, but there are also bigger packages that carry a lot of data sets or functions that obviously takes longer. Now you might think, okay, we now install package Gini. Now we can use the function package inec. We can now use the function Gini. However, this is still not the case. So if you do nothing else than just writing down the name of the function, only searches for functions of that name in base R. So you need to tell R that the function Gini actually resides in the package inec. Now, in order to do that, you first write down the package name, and then you add two dots, and you already get a preview of all the functions that are defined or objects defined within that package. And we already find here our function inec, which we can use to measure the Gini coefficient of a certain vector. Now, if you press enter and say we have a vector with the elements 1, 2, 3, 4, 1, 2, 3, 5, press enter, we now get as a result the Gini index of that vector by telling R that first here look in the package inec and then use the function Gini from that package. Now, I really recommend you, especially in the beginning, always use this strategy to actually use functions or objects in general from a given package. Because if you read that code, you immediately see that this function here belongs to that package. But sometimes you're using a lot of objects from one particular package. For example, you might want to use many different objects defined within the inec package. So in this case, it might become a little bit tedious to always write inec ... What you can do is to add at the beginning of your script, and that is very important. You should always do that at the very beginning of your script. You could add something called a library call. If you add library and then write down the name of the package, in our case inec, then you will be able to use all the objects defined within inec below without making this explicit. So if we just use Genie, already indicated, Genie from the vector of 1 to 5, it can't find the function. If we run this command and then again call this call this function, it does work. So what this library call does here is actually it's so-called attaches a package, meaning that R doesn't only look in base R for function for object definitions, but also in the package inec. Now, that is very convenient if you call objects from a package many times, but it can also be a little bit confusing because if you only look at the script, for example, like this, there's nothing that tells you that the function Genie is actually part of the package inec. So in this sense, this here is more explicit, and in general it's the better option. But if you're lazy, it's also okay to use library. I actually recommend to you, even if you're using this approach, that in the beginning of your script you always add a library call, because that makes explicit to everybody who uses your script that in order for the code to work below, you need to have the package inec installed. So that's definitely a good idea. To make that explicit. Now at this point, I want to put your attention to something that is very important to practice, and that is called masking. Now, I already told you that packages are written by many different people, which is a great thing because you can basically build on the shoulders and ideas of many, many different beautiful minds. However, at the same time, that comes with a potential problem. Now, it is not unlikely that two packages built by potentially two different people assign the same name to different objects. And if you then attach both packages, the assignment of the earlier package will be overwritten by the latter one. So if there are two packages and both define a function called, say, Genie, then of course if you write down the name Genie, it can only point to one of them. And what is happening in practice is that all potential function definitions of the first package will be overwritten by the object definitions of the second package. And this process of overwriting definitions of a package that has been attached before, this is called masking. And it can be very annoying in practice, and it can lead to very weird error messages because you're thinking you're using one function, but in fact you're using another one because another package has masked the original function call you are actually wanted to make. Now let's try this out with two packages, dplyr and plm, and see how masking works in practice. Okay, so assume we have a script where we first call the package or attach the package plm, which is a package used to analyze panel data sets. And we also attach the package dplyr, which is a package that is used for data wrangling purposes. We will learn about both packages later. Now, if we attach the package plm, we see down here in the console that there's nothing wrong during the attachment process. So we could now actually use all the functions of the PLM package, like for example the function lag or lead, which are functions that help us to navigate panel data sets. Now if we also attach the package dplyr, we see that there are a couple of messages here. So instead of just attaching the package, R is giving us a little bit more information. So we see here that the following objects are masked from package plm. That means the functions between lag and lead or these objects are objects that are defined in plm and dplyr. We also see that there are some objects masked from package stats and base. Now you might wonder, I have never attached the package stats. Why is R telling me that? Now there is a number of packages that are automatically attached if you start R. So in some sense for you, it's practically useful to think of them as being part of base R. And in the current case, this applies to the functions filter and lag and these functions here below. But here we want to focus about the conflicts between the packages PLM and dplyr. Now, what does it mean if dplyr masks functions from the package PLM? Let's illustrate this via the function lag. If we just type in lag, we see here already that if we just write that down, the function lag will come from the package dplyr. You can see this by this name here that is given to you during the preview of RStudio. We know from here that there is also a function called lag that is part of the package PLM. Now, what can we do if we want to use the function defined by the package PLM? Just because it is masked doesn't mean we are not able to use it anymore, but we can still use this functionality with the name of the package, the 2 dots, and then use the call the function lag to use the function lag from the PLM package. Now, if you actually just write the function name without the brackets and you press enter, you get a preview of this function, and just by comparing the one from dplyr and PLM, we see that they are coming from different namespaces, referring to the different packages they are coming from. However, also as you see, this is not entirely true. Because here actually PLM adjusts a function that is provided by the package stats, which means why here we have namespace stats. If you really want to know where a function comes from, it's actually best to write down the name of the function, lag in this case, and here you see where it comes from. And I mean, if you're using the more explicit way to actually address the function, then it's clear that it comes from the package PLM anyways. So therefore, I strongly recommend to you, whenever you know that there's some masking in a process, always use the more explicit way to address objects by using the 2 dots. In this case, while it is not necessary, always write dplyr.lag, because what would happen if you restart R and you switch the sequence through which you actually load in the packages, you will see that if you're now using the function lag, you will use the one from PLM. That means masking always works in the sense that the package that gets attached later overrides the definitions of the package that has been attached first. Meaning that if you write a longer script and for some reasons you switch the sequence of the library calls here in the very beginning, your script might not work at all and you will get very cryptic error messages. So please, always, if you know that masking might be a problem, use the most explicit way to address the objects in the package. And you might wonder actually whether masking is a problem at all, because you might have emptied here down the console and you're not sure whether actually masking is a problem or not. Well, no problem. There is a function conflicts of base R. You can just press enter, and then you see actually all the function or object names where masking is a problem. So you see here the function lag that is being masked currently, and that means whenever you are calling one of the objects that's given to you by the function called conflicts, then you should always use this way of using the double points to address functions explicitly, and then you will have no problems with masking at all. But as I said in the beginning, this is one of the main sources of errors, in particular in the beginning, so be very, very mindful about the problem of masking when using R packages, especially when you're using more of them at the same time.